Good afternoon, all of you. So today we'll be seeing a different, totally interesting session. In today's class, we'll be learning more practicals. So far, we have learned theory. So I will be teaching you how to write Python programs for the data science, whatever you have learned so far. How to find out mean, median, mode, how to find out standard deviation, how to find out variance, and so on. Okay, so we'll have a small refreshment about what is NumPy, what are the packages, and so on. So this session basically is a hands-on training. I'll teach you how to create NumPy arrays, what is arrays, what are shapes, okay, what is square matrix, what is eigenvalues, eigenvectors, mean, median, mode, standard deviation, row means, etc. Okay, and when I'm taking this class, I assume that you have some prerequisites. You might have learned some basics of Python somewhere or the other. Okay, so this is the first program. I'm going to explain this program. In this program, what we are going to do is that we are going to create an array called as array1, and I'm giving it name as ARR1, and I'm going to simply print it. I have another one array, array2. This is a two-dimensional array. The first instance, we are learning how to create a one-dimensional array. In the second instance, we are creating a two-dimensional array. And we are printing this array again. Okay, so I'll show you how to do that. This is my editor. This is Google Colabs. Those who are familiar with Python, those who can use Colabs, you can use it. Otherwise, you have another option called as Spider. I'll show you that also here. This is Spider. The same way like you type in your Google Colabs, you can do it in Spider, and in your exams, you may not be allowed to do it in Google Colabs because you need internet connection for that. You may need to do it in Spider only. Okay. But I won't be doing the programs in Python because I'm more convenient with Colabs. Everybody, it's almost the same. It's a different ID, that's all. So typing here, you're typing it there. Others, everything is same. So this is the way you do it. These are some programs which I have done for my projects. But this is the way you can write your project in Spider also. If you want to learn more about working in Spider, you can come and meet me. I'll give you these guidelines and I can teach you how to do that. Okay. So here, do you know what is a list? All of you, Python list. Yes, a collection of data, right? I'll begin with some differences between NumPy arrays and lists. Okay. So I want you to make a note of all whatever we are dealing with here because you will be having quizzes and viva and so on. Okay. So now I'm going to create a small list in Python and I'm call it as students. Students, students. And I am I am creating some numbers. Maybe for my subject foundations of data science, I'm creating some marks for each student. I'm putting it in the roll number wise. I'm putting it as 81.6, comma 72, comma 63, comma 63.9, comma 55.6, 4 or 72, etc. So this is a statement. You have a variable. The variable name is students. You can give this is a Python variable, and the name I've given it as students. You can give it as X, Y, Z, FDS, marks, or anything you can give. You can give it as marks or anything. Okay. When I run this, to run this program, what I will do is that I'll click this play button on the top left. Okay. In this button, when I run this, if there is no errors, I will get nothing. I'll get a green tick saying that this is okay. But if there are errors, I will get the errors written down there. It will take some time because the first thing, it is getting connected to the Google server. So the first statement may take some time. But you see, I got that tick and 0 seconds. If I made any mistake, say for example, I forgot to close the bracket, I'll get an error immediately saying that incomplete input or something like that. Okay. So this means that my Python statement has been executed successfully. Okay. So now if I wanted to know what is there in the variable called as students, if I simply type students here, I will get this displayed here. Okay. Is that clear? This is a variable. Students can take much different variables. So if I'm giving here students is equal to 25 and then I am typing printing students, what will happen is that although you have something else, your output will be 25 only. Okay, so it means that a variable name can contain multiple elements with different data types. Okay, what are data types? I presume that you already know what is data types and so on. I don't need to go into all those basic details. I don't want to go into those basic details. I'm assuming that you know everything on that. Okay, right? Now I just wanted to print students. I'm multiplying the students with 2. And students is a list. List is a collection of data. So what I'm getting, I'll just check what is the output. Now I should run this once again so that it goes back to the list. See, I'm not getting this each value multiplied by 2. I'm getting this 81.6 and this same list again repeated for 2 times. This is what happens when you multiply a list. This is what happens when you multiply a list. Okay. So what happens, like characters, it gets multiplied, the number of times it gets repeated. Okay. So this is what happens with a list. Now we'll see what happens with a NumPy array and what is a NumPy array. Here, list can have multiple data types. Say for example, I can create another one. I can call this as Akash. and just run this. Still it is correct. Now if I print this again, I'll have 2 times Akash written here. That's it. So list can have multiple data types, and when you multiply a list by say 2 or 3, whatever you do, the number of elements in the list gets repeated as many number of times you would like it to happen. Is that clear? All of you? So we have a library in Python called as NumPy, numerical Python. Okay. In order to use this NumPy library, you need to first import that. It is an external package. You need to import that and use it. Okay. So for that, what we do is that I am simply importing NumPy. And I'm going to run this statement just to see whether it is correct or not. It's correct because I got the green tick and says 0 seconds. Now I just wanted to print the value of pi, for example. NumPy has so many constants. NumPy dot pi. Now if I run this, I'll get the value of pi. Okay, so this is a constant. You can use this NumPy. You have so many constants also. Similarly, you have another package called as SciPy, scientific Python. This is now numerical Python. We'll do almost all numerical Python calculations and what else to say. All these in our NumPy package. Okay. So whenever I want to use any constant, any value. Now, if I simply type pi, I will not get this value. I'll get it as pi is not defined. Pi, what is pi? I don't know pi. That's what this interpreter is telling. The difference between a compiler and an interpreter is that it's a very common interview question that is asked in many, many places. What is the difference between a compiler and an interpreter? Is there anybody in this class who can answer this? For example, you have a C compiler, you have an interpreter, Python interpreter. In a compiled program, what you do is that you have a set of instructions, and all these instructions are evaluated at one stretch at the end of the program. But in an interpreter, we are evaluating it line by line. So Python is an interpreted language. That means every line by line you are executing this Python program. Is that clear for all of you? Everybody, Ravi Shankar, you are able to understand? Is there anybody who cannot understand? You tell me, I will repeat it again. So, but when I type numpy.py, where this is object-oriented programming, this NumPy is a library. It has a class. We are importing this. I'll tell you in detail about this when I teach you data structures, data science lab in detail. Okay. So now, if I use numpy.py, what happens is that I get the value of pi. Right? Same way, if I want to create an array, I will use numpy.array. Okay. But every time I'm typing numpy, it's very difficult. No? So I wanted to use it as np, or np is a standard convention. We never change it because it is the way we do it. Okay. So we call this as aliasing. Aliasing means you have a big name in your house, you are called as with a sweet short name, right? Yes or no? You have a big name. வீட்ல என்ன கூப்பிடுவாங்க? How do they call you at your home? Your parents would have very interesting, beautiful nicknames, right? Yes or no? So you will be called by those nicknames, right? But the same way, NumPy is difficult, so we call it by a nickname. But nickname also, you should have that name to be standard. You cannot keep changing it. You cannot use anything. You can use anything else grammatically and technically, but you should not use anything like that. We have something called as PEP convention, where we have a standard way of doing it. One of the basic requirements for a programmer is that his program should be readable and interpretable. That means that if you write any program, any big code, anything, it should be understood by others. Only then your program is successful. Because you work in companies, your code need to be used, reused in several places and several number of times. So we have some conventions. We give some names. Say for example, here I use students so that the variable is easily understood. Right? So easily understanding a program is a primary requirement for a good program. Is that clear? So we always use NumPy as NP as a basic convention. So we always use NumPy as NP. Okay, everywhere we do it like that. Now if I run this, I'll get an error. No, I'll get this because you can use any names. Okay, NumPy dot py. I can also use np dot py now. Instead of typing the whole NumPy, I can use np also. But if I don't give this aliasing, I'll get this as error. Okay, all errors are important. Now I get this as an error. I should get that np is not defined because it has previously running on that. Otherwise, this is an error. See here, this one, this np is not defined actually. Okay, there's some other place where I've used np now. I just would like to reload this so that I can display that error to you. Because we have some problems with that thing is being that is getting connected again. So basically it is a standard convention everywhere we are using it by this way. So import NumPy as NP. Okay. Now see here. Here I am creating a single dimensional array. Okay. So how to create an array? One dimension array. Okay. I'll tell you different ways of making array very easy. First one is that you can convert your list into an array very easily. You have already created a student's list here, right? But you cannot create it with this Akash. I'll show you that. Now, st underscore array is equal to np dot array and I give students. Okay. And now st underscore aar, if I type, I'll get an array of this type. Okay. Is that clear? So I have converted my students list into an array. Now what happens if I would like to multiply it by 2? I got an error because something is wrong here. I have this Akash Oh, I cannot multiply by 2, right? So I'm removing that, Akash. I'm again running the statement. Now I am again, yes, I'm again running it. Now let me try what is happening. See, I'm getting all the values internally multiplied by 2. So now I have a students array. I call it as st underscore arr, where I have some values entered into it. And when I multiply it, I'm getting this. Okay. So numerical Python is basically used for numerical calculations. Now I just wanted to tell you something like we create, I wanted to know the shape of an array. Array is something that is like matrix. Okay. Now here you can see that here it is 72 and here it is 72 point. It means that it means to say that it is 72.0. So whenever you create an array, it gets converted into a single data type. If it is an integer, it will be an integer. If it is a double float or whatever it is, float, basically it will get converted into a float or a decimal. So here what happens is that we have 5 elements here. 1, 2, 3, 4, and 5. And this is a single dimensional array. That means that you have a one row and n column matrix. Okay. 5 cross, say 1 cross 5. Okay. Is it understood? Now I wanted to create two-dimensional arrays. We'll be working on very difficult mathematical problems and statistical problems as we go on. So you need to know how to calculate, how to create two-dimensional arrays. Okay. So now I'm creating a two-dimensional array. Okay. For example, marks into subjects or something like that. Okay. Let me call this matrix as A. And Python is case sensitive. I believe you know that. That means that you cannot interchange and use small letters and capital letters. I'm creating an array called as, here I'm creating two lists. One is a big one and the other one is small one. 1, comma 2, comma 3, comma 4, comma 5, comma 6. How many of you can tell me what is the shape of this array? Yes. How many of you can tell me correctly what is the shape of this array? 2 rows and 3 columns. So why I asked you this again and again is that you can see that the first one is the number of rows, second one is the number of columns. Is that clear? Now, I believe that all of you can create arrays, you can create matrices, and you can start working with matrices. Matrices and vectors. Okay. So I will next tell you how to create or how to populate arrays automatically. You have two methods through which you can create arrays automatically, right? So one is B is equal to NP dot A range, okay, 0 to say 100 with step size 1. So what this means is that I want an array to be created with values starting from 0 to 100 with one step. That means this array will contain 0, 1, 2, 3, 4, 5 up to 99. Now if I run this and then if I print B, I'll have an array consisting of 0 to 99. If I put it as 10, I'll get 0 to 9. So this is one way in which I am populating an array. Okay. That means I'm automatically giving values to an array. Say for example, I wanted your roll numbers to have an array. So how many students are there in your class? 55, right? For example, okay, let it be something 55 to 56. So what I can do that I can create 1 to 55 so that I will have all your roll numbers. So I have all the roll numbers up to 54 or 56, right? So on. And now I can do some mathematical calculations also with that. I can put B into 3, say for example, then I'll get each value multiplied by 3. Okay. Similarly, there is another one method called as linspace. C is equal to np dot linspace 0 to 100 and 1. So what is the difference between a range and linspace? In linspace, here I will be giving, instead of step size, I will be giving the number of values I wanted this range to be equally divided. If I give this as 2, I'll get two values, that is 0 and 100. If I give this as 3, what I'll get the range divided into 3 values, 0, 50 and 100. If I give it as 4, I'll get this as 0, 25, this 33.66.67 and 100. It takes the whole range, it divides the whole range equally into the number of required halves or required parts. Okay, this is another way of populating this array. Put it as 5, you get 5 values. The length of the array finally generated will be the last argument that you give inside a length space. Okay, so is there any questions, any doubts? So we have created a single dimensional array, two-dimensional array. I want you to practice this and learn by yourself to the maximum how you create arrays. So we have seen how to print the shape array. We will see how to the dimensions of arrays. So here, this one, right here, so we have a dot shape, a dot n d. So dimensions means actually it is giving you the number of rows or number of lists inside one. Okay, that's the dimension. And size we have to see, right? A dot size. Size will contain the total number of elements, right? So total number of elements inside this array. Is that fine with you all? Size will contain the total number of elements inside an array matrix. We are going to do multiple matrix manipulation as we go on. Okay. So shape of an array is a tuple. I presume that all of you know what is a tuple, right? Is there anybody who doesn't know what a tuple is? 2, comma 3. This means that the tuple, first argument is 2, second one is 3. This means that we have 2 rows divided into 3 columns. Okay? So I think, uh, shall we proceed with mean? NP dot mean, how to find the mean of a set of values. So next, I have an array B, I have an array C. The C is having values from 0 to 100, 0, 25, 50, 75, 100. Now I want to find the mean of all the values inside this array C, for example, or B, wherever it is. NP dot mean C. Okay. So I'll get the average value of all these things. 0, 25, 50, 75, and 100 divided by 4. Okay. So very easily you can find out mean, and see why it comes as np dot float 64 and so on is because It is object-oriented programming, and everything is an object. In other classes, I will give you a detailed explanation of why we have this. Okay, so actually SciPy import stats, this is not required for finding out mean. Mean here I've given you an example where we have an array 1, 10, 20, 30, 40, 50, 60, 70, 80, 90 and 100. So if you want this to be generated automatically using linspace, what you will do? Data is equal to np dot linspace, then 10 to 100 with 10. Now if I print data, we'll see what is that. 10, 20, 30, 40, 50, 60, 70, 80, 100. Right? This is another very easy way of doing it. Now I want np dot mean of data. I should get the value to be 55.055. Right? So easier way, x is equal to or MEA and then type MEA so that we get it as 55 and we can use it again. Is it okay, all of you? Now, this is all what we have been dealing with in a single dimensional array. So what about this A? A is a two-dimensional array, right? So what happens when I give mean of a two-dimensional array? So this is A, okay? Here, say for example, I type np dot mean of A. What happens? It gives me the value of all the elements, this one plus this one, and gives me the average of that. Am I right? Okay. What is 1 plus 2 plus 3? 6. 6 plus 4, 10. 10 plus 5, 15. 15 plus 6, 21. Divided by 6. Right? Now, see, I don't want to find the mean of all the values, but I just wanted to find the mean of the row, first row wise. Okay. So what I'll do is that I'll give axis is equal to 1. Okay. So now what happens is me the mean of 1, 2, 3. That is 3 plus 3, 6 by 3, that is 2. Right? 4 plus 6, 10, 15. 15 by 3 is 5. So I get the row-wise mean of each elements if I give this axis is equal to 1 in np dot mean. Okay? Understood all of you? Now what happens if I'm going to give this axis is equal to 0? I'm going to get 3 values, this column-wise values, 1 plus 4, 5 by 2, 2.5. 2 plus 5, 7 by 2, 3.5. 3 plus 6, 9 divided by 2, 4.5. So all whatever I'm getting the output is in terms of array, right? It's all arrays. Okay, so that it is interpretable, editable, we can do more numerical calculations based on that. So how to find out row wise means of a multiple dimensional array? I'll give you this as your lab experiment and assignments. So do not completely rely on the material alone, whatever I'm giving you. You need to listen to my classes, and you are open up, you are free to open up with any questions at any moment of time. If you do not understand anything in the class, I want you to wake up and smell the coffee, right? I want you to understand the reality. Okay? I hope I'm clear with all of you, right? Is there any clarification required anywhere? Okay. So these notes are shared to you as slides because these are all practical classes. Unless and until you really understand the depth of it, you cannot do it. So we have this median coming up. We have to find median and mode. Okay. Is that fine? So now you can write a program to find the row-wise means of a two-dimensional matrix or a two-dimensional array. So far so good. Is there anything that any questions? Any concept that you want me to explain once again? So coming to median. What is median? Okay. So in our theory classes, I've given you some problems for finding out the median, right? Can any one of you just go back to the notes and let me know the numbers where you have found out the median? One case for odd and one case for even. You tell me the numbers alone, right? Okay. Now values is equal to np dot array. Then tell me the values now for median, right? 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. So how many values are there? How you will find out the number of values? Values dot length. No, this length can be used only for uh, this thing, na? List. L1 is equal to. So I'll give this as L1 dot length. Okay, L1 dot length. Sorry, it is length L1, so I'll get it as 10. So let me check whether it works out for values also. So it doesn't need a list. So 10 is an even number, right? So how do you find out the median for an even number? What is the formula for finding out the median of an even number? Yes, the center two values plus divided by 2, right? So what is that you get? 75 plus 80 divided by 2, right? Yes or no? 75 plus 80 divided by 2. So you get 77.5, right? NP dot median of values. You got this 77.5. So this is how you write a program to find out the median of a set of data. All of you understood? Now this is important because we do it programmatically. We have so many, all the calculations what you have done so far is very simple, easy. But what happens if you have thousands of data? Okay. So what happens if you have an Excel sheet which contains so much of information? So we need to find out the average values, we need to find the median, we need to find mode, etc. for a large number of values. So what we do is that we use, so we have calculated median, we have calculated mean, we have calculated row wise mean, you know how to calculate column wise mean also, you know to calculate row wise means also. In Excel sheets, we have all these formulas. We have those who are familiar with Google Sheets or Excel can easily know that sometimes we may need to find out the average. If I want to find out the average, I have a data set of all your marks. Okay, let the first row be your names. Second row, your sub mark in the first subject. Say for example, engineering mathematics. Then you have the second subject, oops, third subject. If I want to know the subject wise average, what I can do, I need to do it column wise. If I wanted to find out student wise average, student wise median, student wise which subject he has scored low, I have to do it row wise. So you know how to do it row wise, you know how to do it column wise, right? Yes or no? Later on, the coming classes when I start taking pandas, I will teach you how to import an Excel sheet into your Python program, how to calculate the values, re-enter it to the Excel sheet, and how to do a large number of processing in Excel using Python. Okay, Excel is a very wonderful software. So either you can do it in Excel or you can do it without that also. We have a framework in Python called as Pandas, a library. Not a framework, it's a library. We can use this Pandas for creating structured data. Pandas is the most important data science library. So we'll be learning data science through Pandas. I'll be giving you in-depth lectures on Pandas. Okay, this is useful for you in multiple ways. So next we have to find out mode, right? So this part I believe everybody understood. For even values, the same way for odd values also you can find out. Say you can give these values. Odd values very easy, there is no calculation required. There is the central value. So maybe if you want you can do that also. Values underscore is equal to np dot array 10 comma 20 comma 30 30 comma 40 comma 60 50. Okay, so your answer should be 30, right? Values underscore 1 dot, no, it is np dot median values, np dot median. So the answer should be 30, right? Right? So now you know that for a median you should have the values sorted, arranged in an ascending or descending order. So let us see what happens if I'm giving something that is different, say 60 here, and say 90. It is automatically sorting and then finding out the median. So you don't need to sort a set of data to find out its median like you do manually. Okay, you can give the value as you like. The things will automatically get itself sorted out. Is that okay? So for finding out mode, we need to have, or we generally use stats. Stats is a method in SciPy library. So here we have this data value, right? Already entered this value, right? So what is this values one, right? From SciPy import stats. Okay, stats dot mode. Stats dot mode values underscore one. Okay, So you don't have any mode, right? Because all values are being the same one. Now I put it as 60, 60. And now when I run this, I get this as 60, right? Okay. If this is not 60, it is 40. When I run, I'll get the first value as the output, that is 10. Okay. 10. That is, you don't have this. 10 is having only count 1. See here, number of times it is coming. This count is telling you how many times it is being repeated. The results of mode. You put this as 60. Here, you will get it as 2 now. Count is equal to 2, you will get it. And the value of mode is 2. You put another 60, you will get that to be 3. Okay? Is that okay? So far we have studied how to find out mean, median and mode. Now we will study some more statistical methods to find out the standard deviation, variance, etc. So before I proceed, I want a confirmation from all of you that all of you are comfortable with whatever I've taught so far. Am I right? Yes or no? Is there any doubts? Anybody? Shall we proceed to standard deviation? We have done some problems in standard deviation in our very simple direct. You just need to put np.std data and then print the standard deviation. Whenever you use spider or some other kind of, IDE, you need to use print and write. Okay. Since I'm using Colabs, I don't need to print. I just need to put the value. I get it value print. Now let's go into dive into our previous these things. Now tell me any of the values of any of these standard deviations which you have already found out. Tell me. So I'll make it as data. It's data is equal to np dot array. Tell me the value. 51, 55, 60. The same one. Previously what we have given, the same one. This one, values. Right? So it is very easy. I don't need to work on that. I'll give it as np dot std values. DEV, that means deviation is equal to, or V itself is equal to np dot std values. What is the answer that you have got? 14.361, so on. Is it right? Is it okay for all of you? So here the data is different, so you got a different one. So you want to find the variance np.var, that's it. Right? This I call it as SD, and this I'll call it as VAR is equal to np.var values and then VAR. So variance is 206.25. Is that right? Is that right? So now you know how to find out standard deviation, you know how to find out variance. So next, calculate row-wise means of this and tell me the answers. I have a two-dimensional array with 4 columns and 3 rows. It's a quiz time. I want you to calculate manually and tell me. Those who have laptops can do it in laptops. Others can do it manually and tell me. You can use your laptops. You can write a program to find out the row-wise means. Okay. Of this matrix. Okay. I've just copied and pasted. I don't know whether it's fine. Yes, it's fine. Now, write a program to find out the row-wise means and column-wise means of this particular matrix. When I give this as np dot mean, axis is equal to 1, you are doing row-wise mean. So you get 2.5, you get 3 values. Mean of this, and mean of this. Okay. If I give axis is equal to 0, I will get 4 values. 1 plus 5 plus 9 divided by 3. Same way, 2 plus 6 plus 10 by 3 and so on. Right? So this is how you find out. I get 5, 6, 7 and 8. Is that okay? So this is how you find out row-wise means. Same way you can find out column-wise means if you give the axis. 0 axis means this one. Axis 1 means this one. Overall mean means it will just you give mean, it will find out all the values, sum up all the values and give the value of the average of all the values, whichever row, column, whatever it is. Now, standard deviation of means. Now, this is something that we use in our data science process where we find the standard deviation of means. So here I have this now. Now the thing is that you can get a single value, standard deviation of all the means. Okay, this is probably a very important metric that you will be using for several applications in data science. So now let me put this as something, say R is equal to, okay, and next I wanted to find out np dot std of R. S is equal to, sorry, S is equal to np dot std of r, I will get the standard deviation of r. So r is not defined because I have not run this. Now I get that standard deviation to be 1.1180 some values, right? This is how I calculate the standard deviation of row wise means. And this is an important metric. We'll see where we are going to do that. Have you see many of these applications are not only for data science. This is used for computer vision. How does computer vision algorithms work? You know that about? Have you ever wondered about how it works? You convert an image into nothing but a matrix, and all manipulations are done with matrix. In computing, what we cannot do anything without converting these into numbers, and all our processing is done with the help of these numbers. Okay, so you have to concentrate on that, and you have to understand that we need this not only for data science subject, we may need it for machine learning, we may need it for deep learning, we may need it for computer vision, we may need it for natural language processing, and so on. All these domains currently require a very strong knowledge in basic statistics. Let me repeat it. Without probability and statistics, we cannot proceed. So please revise all your statistics concepts. So standard error of a mean. So for the sample means, we call it as standard error. The next important thing, eigenvalues and eigenvectors. Can any one of you tell me the significance of eigenvalues and eigenvectors? A square matrix A is an eigenvector. An eigenvector is a zero, non-zero vector V that when multiplied by A only changes by a scale factor called as eigenvalues. How do you find out the eigenvalues of a matrix? You remember that? We have studied in our basic mathematics how to find out eigenvalues. You remember that? What are eigenvalues and eigenvectors? So you have a square matrix A, its dot product with the eigenvector will give you some lambda with its V. So this is the significance of eigenvalues and eigenvectors. We have infinite amount of applications with respect to eigenvalues and eigenvectors, and we may very often need to do so much of manipulations with eigenvalues and eigenvectors. So we have created a square matrix here. I want you all to create a square matrix here with this code. So this is how you create a square matrix. A matrix which has both rows and columns equal is called as a square matrix. Okay. So now, very easy. This is the core of it. NP dot linalg, linear algebra. Linalg stands for linear algebra. So all our problems will be related to linear algebra. So now I'm going to find and check whether these eigenvalues are correct or not. So I'm creating another one. I'll call it as AE. I'll run this, and now I'm going to find out the eigenvalues and eigenvectors using np dot linalg. Okay, and this should be AE, right? Because I've given AE here. So this is a function in Python that is returning two values. The first one will be eigenvalues and the second one will be eigenvectors. So if I copy this, I'll get this eigenvalues. And if I run, I'll get the value array 5, comma 2. See here, eigenvalues is a matrix which I get 5 and 2. I believe that all of you know how to manually calculate the eigenvalues. Is there anybody who does not know how to calculate eigenvalues? Please raise your hands. Okay. So you can manually do it by using this characteristic equation, determinant of A minus lambda I is equal to 0. And this is this lambda available here. I is the identity matrix and A is the matrix that we have created here. Okay. Similarly, eigenvectors. I can simply use this and print the eigenvectors also. So I got the 4 values for eigenvectors. So you get, so now how to retrieve a value in a matrix? That we'll conclude today's lecture with that, a very simple one. Now see, suppose I wanted the number 6 that is in the second row, means second row and second column. So how will I get that value? Okay. So I got this value 6 here. Okay. Matrix 1, 1, 1. Matrix 0, 1 means I'll get 2. It begins with 0. Everything begins with 0. All indexing begins with 0. Okay. So there is a lot of things that you can learn. You can learn about slicing a list. You need to do some small programs with respect to slicing of a list and so on. Okay. So that's the end of today's lecture. I'm sharing you this PDF. I've already put this in your class group. I'll share this in your classrooms also. So these are some practical ways of finding out the things that we have studied so far theoretically. So I wanted, is there any more questions that anybody would like to ask me? I am open up for discussions now. Any questions? So thank you very much for attending this session. You are always free to ask me questions in either way. You can communicate to me in all means, including my YouTube channel where you can post my questions also. So thank you all. Thank you very much.